Hi, welcome to Stat Lessons. Today we will be continuing with the hypothesis testing. Today I've taken 2022 May-June paper. Let's start with this question. In the past, the mean height of plants of a particular species has been 2.3 meters. A random sample of 60 plants of this species was treated with fertilizers, and the mean height of these 60 plants was found to be 2.4 meters. Assume that the standard deviation of the heights of the plants treated with fertilizers is 0.4 meter. Carry out a test at 2.5% significance level of whether the mean height of plants treated with the fertilizers is greater than 2.3 meters. So in this question, it is not mentioned what type of a distribution is it. At the same time, we know that this is going to be a hypothesis testing. So let us find out what kind of a hypothesis testing is this? At the same time, what are the given data? Now, in the past, it is given that in the past, the height of plants of a particular species has been 2.3, which shows that the number 2.3 is the null hypothesis. Also, you can see that 60 plants were treated with fertilizers, and the height seems to be 2.5. That means this is the observed value or the test stat. Because in the past it was 2.3. Now, the latest findings or the latest height of what they have checked is found to be 2.4, which means that this is the test stat with which we have to go for hypothesis testing. Then the remaining numbers are the data required to calculate this. For example, we have here standard deviation, the test significance level. So let us start with writing down the null hypothesis, H naught, such that mean is 2.3. This was seen in the past. The alternate hypothesis says that the mean height has been improved or increased or not. That means whether it is greater than 2.3 or not. So it's greater than 2.3. The other data which is available in the question is the sample size, being 60, standard deviation, which is 0.4, the test stat X bar, which is 2.4, and alpha, which is 2.5%, which is significant level. So now we have seen that all these value is being given to us, but still the distribution is unknown. So if the distribution is unknown, what distribution can be used over here to do the testing? Now, as we all have gone through the central limit theorem, it says that if n is greater than 50, the distribution which is unknown over here is approximately normal. So hence, here the n value is 60, more than 50. Hence, we can use a distribution, a normal distribution to do these further calculations. So let me draw the graph of what is given to us, which is approximately normal. And the population mean is given to be 2.3. And our null hypothesis is 2.3. Our alternate hypothesis says that it is more than 2.3. So our rejection region lies somewhere here, which is equivalent to 2.5%. So this is our critical value, the boundary value, we call it as our critical value, C. Now the observed value 2.4 is what we are trying to locate. If this is in this region, we call it as rejection region, then we say that the H naught is rejected. If it falls in this region, we can say that the H naught is accepted because it falls in the acceptance region. So this is what we are trying to check. Now to do this, we need to take the help of the standard normal distribution. Now we know that this distribution is drawn based on X bar. So the standard normal distribution is drawn based on C. So when it is standard normal distribution, 2.3 becomes 0. And the boundary line, which comes over here, is converted to Z. The percentage is the same, 2.5%. So we are trying to locate where is this 2.4? This 2.4, 2.3 is now become 0. C has now become Z. Now 2.4, when it comes down to this graph, where is it going to fall? This is what we're going to check. So for that, first of all, let us see what does this value of C correspond to in Z here. So for that, we write significance level is given to be 2.5%. So significance Z, that means the value which is 2.5% or the probability or the area over here is converted to Z value. And what will happen to its Z value? So what we're going to do is we're going to take the pi inverse of 0.025, which is the same as pi inverse of 0.975, and you will get from the table 1.960. Now, since this is a right-tailed, 1.960 is going to be positive. All right. Now we check with our 2.4. That is our test stat is 2.4. Converting this test stat to Z value is 2.4 minus 2.3 over 0.4 over root of 60. Now by doing this, what are we trying to do is this 2.4, what we have it here, we are converting to a Z value. So that seems to be 1.936. So now it is quite obvious. Our boundary line, which is C, that corresponds to Z, this was found to be 1.960, and 2.4, this value is 1.936. Now we can see that this can be compared and check where 1.936 falls. You can see that 1.936 is less than 1.960. This corresponds to 2.4. So we can say that 2.4 falls in the acceptance region. Therefore, accept H naught. So we have done the testing part, and we have seen that there is no evidence that the treatment of fertilizers has got no effect, or can say it's not greater than 2.3. As you like, you can write down the conclusions, but the main idea behind that is that there is no evidence that the fertilizers, that the species was treated with fertilizers in which the treatment has got no effect on the species. All right, so let's move on to the next question. A certain kind of firework is supposed to last for 30 seconds on average after it is lit. An inspector suspects that the fireworks actually last a shorter time than this. He takes a random sample of 100 fireworks of this kind. Each firework in the sample is lit, and the time it lasts is noted. Give a reason why it's necessary to take a sample rather than testing all the fireworks of this kind. It is given that the population standard deviation of the times that the fireworks of this kind last is 5 seconds. The mean time lasted by the 100 fireworks in the sample is found to be 29 seconds. Test the inspector's suspicion at the 1% significance level. State with the reason whether the central limit theorem was needed in the solution to part B. So by reading all these questions, again, we have come to one particular conclusion that the distribution is not mentioned. What kind of a distribution is? That's why we have a question here in C. So as we see that question there, we need to check whether central limit theorem can be applied or not. For that, again, the value of n, if it is more than 50, the distribution, which is unknown, is approximately normal. So again, the same scenario arises over here, that an unknown distribution, a population distribution which was unknown, is given to be approximately normal because the value of the sample size is given to be more than 50. All right, now coming into the first question. The first question says, give a reason why it is necessary to take a sample rather than testing all the fireworks of this kind. Now, as you know that to test all these things, if you don't take a sample, what will happen to the fireworks? Because once it is tested, it is destroyed. So you can write that statement here. Once tested, the firework is destroyed or not reusable. Okay, anything like that. Now it is given that the population standard deviation of this times that fireworks of this kind lasts 5 seconds. The mean time lasted by the 100 fireworks in the sample is found to be 29. So as you know that in the past, again, on an average, the firework lasts for 30 seconds. Now, the argument or the claim is that, or the inspector's suspicion is that, suspects that the firework actually lasts a shorter time. So they have a suspicion here that the time is not 30 seconds, but it is less than 30 seconds. So we can see that by analyzing the question, we can see that the average time was given to be 30, but the suspicion, but the inspector suspects that it is less than 30. Again, the random sample size is given to be 100. Your test stat X bar, when they tested with from a sample, it was found to be 29. Population standard deviation is given to be 5 seconds. And again, sorry, alpha is given to be 1%. So again, here it is approximately normal. because n is greater than 50. So I'm drawing a bell-shaped curve, which is given to be 30. This time it is left-tailed, so to the left side, and that is 1%. The critical value is here. Now to take the help of standard normal distribution, this becomes 0. This comes down over here, z. This is again 1%. Now the test stat 29, the observed mean. We need to see whether this mean falls here or it falls in the rejection region. So for that, we can't take 29 as such here. So we have to convert this 29 to another value, which is called z. All right, test stat z. So for that, first of all, let us know what is the significance or the critical z. So I'm going to write here significance level is given to be 1%. So significance level z, we call it as critical z, is phi inverse of 0.01, which is again phi inverse of 0.99, which is equal to 2.326. But you should always know that since it is coming on to the left of the 0, it is supposed to be negative. So also it is a left tail. Whenever it is a left tail, your critical z should be negative. Now coming on to test stat x bar, which is given to be 29. Now converting that to z is 29 minus your standardization, 29 minus 30 over 5 over root of 100, which is found to be minus 2. So we can see that minus 2 is greater than minus 2.326. That means we found this to be minus 2. So this is minus 2.326. So where is this going to fall? It's going to fall in the acceptance region. Therefore, 29 falls in the acceptance region. So as it is falling in the acceptance region, we can say that there is no evidence that the firework is shorter than 30 seconds. All right, so now coming on to the last part of the question, state whether with a reason whether the center limit theorem was needed in the solution to part B. Yes, because population distribution was unknown. All right, so that's all from my side today. So we have gone through 2 questions of hypothesis testing. In both the cases, the distribution was unknown, but still we used our normal distribution as it was approximately normal. And the main idea behind this hypothesis testing is that how to convert all these values from the X bar graph to Z graph, which is a standard normal graph, and then comparing all those values there, and then finalizing our conclusion. All right, thank you for watching this video. We'll see you in the next with another type of question. Bye.